Hey guys, welcome back to part 2 of operations with radical expressions. We're going to jump right into this and look at how to combine like terms using the distributive property and things like that. I'm trying to get my desk in order here. So if we had 5x times 3x, we realize that that's the same as 5 times 3 times x, and we can simplify that then to 15x squared. So with radical expressions, again, we want to do the same thing. If I have 5 times the square root of x times 3 times the square root of x, I'm going to break that apart and do the 5 times the 3 together, and then square root of x times square root of x. Something nice happens when I have the square root of x times the square root of x. That's like saying, okay, I've got the square root of x squared. Well, we know that the square root and the squared are inverse operations, so they cancel each other out and just leave me with the radicand x. So same thing happens if I had the cubed root of some variable and I end up raising it to the third power, the cubed root and the cube cancel out and leave me with the radicand. So in this instance, 5 times 3 gives me 15, and square root of x times square root of x becomes just x. So I'm left with 15x. Okay, so we also have talked about the distributive property in math. If we have 2x plus 3x and we multiply that by 4x plus 5x, what that's saying is this first term is getting multiplied by everything in this set of parentheses, and this second term is getting multiplied by everything in this set of parentheses. So we can rewrite it as 2x times 4x plus 5 plus 3x is being times by 4x plus 5. So I'm going to do that same thing with radical expressions. If I have this and this in parentheses times this set of parentheses, I'm going to take the first term and multiply it by everything over here. And I'm going to take the second term over here and multiply it by everything. So let's go ahead and set it up. It's already been set up, so let's go ahead and now multiply it. So 2 times 4 is 8. Square root of 2 times square root of 2 is just 2. 2 times 5 is 10. Square root of 2 times square root of 2 is 2. Now moving on to this one, plus 3 times 4 is 12. Square root of 2 times square root of 2 is 2. 3 times 5 is 15. Square root of 2 times square root of 2 is 2. So we do multiplication first, then addition. So I end up with 16 plus 20 plus 24 plus 30. That gives me a grand total of 50, 60, 70, 80, and 90. So when I multiply this out, my answer is 90. All right, so moving on. Let's try to simplify this next one. I encourage you, pause the video. We just talked about how to do it up here. I would like for you to pause the video and try this on your own. Okay, so I went ahead and combined my like terms. 5 times 4 is 20. Square root of 3 times square root of 6. Now don't be tempted to say that's just 18. The only time that I can say that the square root symbols cancel out is if it's the same radicand, like square root of 3 times square root of 3. That's just 3. And think about why. Square root of 3 times square root of 3 is the square root of 9. We know the square root of 9 is the same as 3 squared, and that 3 squared and square root, that squared and square root cancel out, and I'm just left with 3. Or we're asking ourselves what number times itself twice gives me 9? Well, that is 3. So don't be confused with square root of 3 times square root of 6 being square root of 18, and square root of 3 times square root of 3 is equal to 3. There's a big difference here. These have different radicands. The only time that the square root symbol disappears, and it doesn't really disappear, we're just simplifying it. The only time that we can simplify it and just totally get rid of it like that is if they're the same radicand. So 3 times 6 is 18. I realized, hey, I can break 18 down into a perfect square. 18 is divisible by 9. So I rewrote it as the square root of 9 times the square root of 2. Once I take the square root of 9, I get 3. So I have 20 times 3 is 60 times the square root of 2. Again, changing the order, 3 times -9 is -27. Square root of 10 times square root of 6 is square root of 60. Again, I realized that, hey, 60 is divisible by a perfect square, that perfect square being 4. So I rewrote it as square root of 4 times the square root of 15, took the square root of 4 and got 2. 2 times -27 is -54, so my answer is -54 square root of 15. All right, and last problem of the day, let's try to simplify this. So we're going to be distributing this to each of these terms. So I have 4 times the square root of 7 times 2 times the square root of 8. So 4 times 2 is 8. Square root of 7 times square root of 8 is square root of 56. Next, I want to do 4 times 3, which is 12. And square root of 7 times square root of 7 would be the square root of 49. We know the square root of 49 is 7, so I can simplify this. 12 times 7 is 84. And I'm thinking here, 80 or 56. What can I divide 56 by that would be a perfect square? So let's think. Is it divisible by 4, 9, 16, 25? Those are my first few perfect squares. I know that it's divisible by 4. I believe that's the largest perfect square it's divisible by. We'll check it and see. So I've got 8 square root of 56. I can rewrite that as 8 times the square root of 4. What is 56 divided by 4? Is that 14, I believe? Yes. So square root of 4 is 2. So I have 8 times 2 times the square root of 14. That can't break down any further. Yeah, it's divisible by 2 and 7, but neither of those are perfect squares. So this is as simplified as I can get it. So 8 times 2 is 16 times the square root of 14. So I have 16 square root of 14 plus 84, and that is my final answer to this problem. Hope that made sense. I will post some practice problems for you guys. Have a great day.